Okay, before we get too deep into this, let's discuss the meaning of an intercept, an X-intercept or a Y-intercept. So I'm just going to make something up real quick that's not on your paper. Let's suppose we're going to graph a line. Now I'm going to be drawing my graphs by hand. Yours, of course, are on paper. Let's see. Let's suppose we're going to graph the line y equals negative 2x plus 4. We're going to graph that line. So when we graph that line, we've been graphing for years, so you know what you're doing. But when we graph this line, we're going to go up to 4, put a dot, and then we go down 2 and over 1, and then down 2 more and over 1. And when we connect them, we have this wonderful line right here. There we go. So we have that line. Now we want to discuss the X-intercept and the Y-intercept. Now in this case, we only have one of each. And with any function, we're only going to have one Y-intercept. We will never duplicate a Y. We will never cross the Y-axis more than once. So we have two intercepts. One of them is here at a certain coordinate, and one of them is here at a certain coordinate. And we need to figure out what that coordinate is. So this coordinate obviously is going to be at 2, 0. This one is at 0, 4. Well, let's go for the obvious here. The Y-intercept, in this case, was the number that was hanging around over here. But let me tell you why that's the case. Because in any slope-intercept form, it's easy to look at it and say, well, it's easy. It's that one right there. Yeah, but here's why. At the Y-intercept, what's the value of x? 0. So if we were going to find the Y-intercept, then we would take this equation and we would plug in 0 for x. Now I'm going to write down the obvious here. We'd have y equals negative 2 times 0 plus 4. Negative 2 times 0 is 0, so y equals 4, which gives us the coordinate 0, 4. And that's where that came from. That's a little more work than we need to show because it's sort of intuitive. But it's not as intuitive with the X-intercept in this situation. The X-intercept obviously is 2, 0, but the same kind of question can apply. What is the value of y at the X-intercept? Well, it's 0. In other words, at the Y-intercept, x is 0. At the X-intercept, y is 0. It's always the opposite. So if we plug in 0 for y in this equation, we'll have 0 equals negative 2x plus 4, and we'll have to solve this. So we'll subtract the 4, and then we'll divide by negative 2, and we get 2, which gives us the coordinate 2, 0. And that is how we're going to find x and y intercepts. What we're about to do, of course, is not linear. And so number 1 says this. Y equals x squared minus 4. We're going to start by finding the x-intercepts. Now the x-intercepts, of course, is where y equals 0. There is also a graph provided for this, and we'll get to the graph in a second. I mean, we can grab our calculator and we can graph it, and that would be great, but let's not go there yet. First, let's find the x-intercepts. For our x-intercepts, we're going to plug in 0 for y. So we're going to go 0 equals, so there's 0, x squared minus 4. Because it is quadratic, we have several options. The option I'm going to jump to first on each one of these is factoring. I'll go ahead and tell you when you get down into some of the other ones, they won't factor. There are a couple on this worksheet that do not factor. And we'll cross that bridge when we get to it. But for now, let's just start by factoring, just to prove a point. 0 equals, and then we'll factor this, and I like to think you know how to do this. So x and x, and two numbers multiply to give me negative 4. Must be 2 and 2, and they're opposite signs, and there we go. And that's great, but now we're going to solve this. So if these two factors multiply to give me 0, then either this is 0 or this is 0. We've been through this. Basically, we will change the signs. So we have an x-intercept at negative 2 and an x-intercept at positive 2. Let's start drawing this on the graph. Now again, I know you have a graphing calculator in your hand or on your desk, and you can probably just type it in and feel happy about yourself, and that's fantastic. But I want you to understand where it comes from. So with the x X-Intercept, and I'm not going to be content right now leaving it this way. I'm actually going to write it as a coordinate. With an X-intercept of -2, 0 and another X-intercept of 2, 0, we're going to have to cross the X-axis twice, of course. So let's just start by putting down that coordinate and that coordinate, -2, 0 and 2, 0. Okay, let's go to the next part. The next part is the Y-intercept, and the Y-intercept is going to be what Y value you get when X is 0. So we're going back to the original problem, and we're going to plug in 0 right there. So Y equals 0 squared minus 4. I think you can kind of figure that one out. You're smart. So we end up with Y equals 4, which really gives us a Y-intercept of 0, comma, oops, I'm sorry, -4. My bad. -4. 0, comma, -4. So we have a Y-intercept at 0, -4. There we go. We're going to draw this parabola. It is a parabola because it is squared. And when we draw it, I'm not a very good artist when it comes to drawing parabolas. It's one of my fallacies as a math teacher. Well, I missed that X-intercept completely. We'll come back and hit it. There we go. We'll try to make the best of a bad situation there. Clean that up a little bit. Make it look like I meant to do it. There we go. And that's it right there. That's our graph. Now, there are 2 more questions, and they deal with the vertex. So we need to find out what the vertex is. Now, there is a shortcut, possibly you may want to call it a shortcut, for finding the vertex. And we're not really going to use it on this one, but we'll use it when we get into some of the other ones. But in this case, the vertex is halfway between the X-intercepts, and it always is if you have X-intercepts. So the vertex is halfway between the X-intercepts, so halfway between -2 and 2, of course, is 0, and you can see that it bottoms out here. The vertex is the minimum point or the maximum point, depending on which way your parabola is facing. So where it asks for the vertex is going to be that coordinate right there, which coincidentally is also the Y-intercept. So the vertex is at 0, -4. And now the last question says, is it a maximum or a minimum? And I think this is fairly obvious. The vertex is a minimum because it bottoms out right there. Okay. While we're at it, and your paper doesn't ask for this, but we're going to go ahead and do this anyhow, real quickly on this one, just because I want to show you something. If it asked for the domain or range, and let's do this. The domain, starting over here, it actually does hit the graph because this extends far enough to where it would hit. So it goes from -infinity all the way to +infinity, because again, it branches out, and you really can't see it based on what I've drawn, but it branches out, and it would cover the entire x-axis. So it goes from -infinity to infinity, and the range will start until, kind of move up until we hit the graph. Oh, it hits right there at -4, and then it goes up from there. So it hits at -4 and goes up to infinity. Never can quite touch infinity, but it does touch at -4. And I'm not going to make you do that for all of them, but I just wanted to show that finding domain and range can go with any type of graph on the coordinate plane. Okay, number 2 is going to be a little bit different. If you need to catch some of this and write it down, you can pause the video here, but I'm about to write number 2. I am not going to do all of these. I'm going to just do a handful and let you finish what I don't finish. So here's number 2, and as we get into number 2, I'm going to start showing you the way to find the vertex and using the kind of I call it a shortcut when it's technically not, but it's kind of a trick that's used. A lot of math teachers hate to use the word trick. It's not necessarily a math trick, it just is something you do. Now, there's a funny explanation for why this little math trick works when you're finding the vertex. And I will explain it to you when you are in my calculus class. And if you're not in my calculus class, come ask me. When you're taking calculus, come ask me. I'll explain it to you why it works. I'll talk about that in a second. So here we go. We're going to start by finding the X-Intercepts. We're going to go a little faster on this one. The X-Intercept is where y equals 0, so we're going to plug a 0 in right there. And because we are solving a quadratic, we're going to have to factor. So, again, they don't all factor. There's a couple on here that don't. I might go crazy and work out one that doesn't. There we go. So we end up with x minus 3 and x minus 1. That means that x is equal to 3 and x is also equal to 1, which as a coordinate would be the coordinate 3, 0 and 1, 0. Let's come over here and we'll plot that on our graph. 3, 1. There we go. Now, I will go ahead and tell you, let's start looking ahead a little bit. The Y-intercept, I'm sorry, not the Y-intercept, the vertex is what I meant to say. The vertex is going to be halfway in between those. So my vertex is going to be somewhere along this vertical line right here. I'm continuing to think ahead, knowing that it's along this vertical line and that this parabola opens up, excuse me, opens up because this is positive. My vertex is going to be down here somewhere. If what I said didn't make sense, don't panic. We'll get to it in a minute. Okay, let's find the Y-intercept. I would like to think that you are completely bored at this point and you can look at that thing and tell me what the Y-intercept is. It's fairly obvious. There is a very easy shortcut to it. I'll point at it right now. That's it right there. Here's the reason it works. 0 squared minus 4 times 0, 0 plus 3, that obviously gives me 3. Yes, it's always that last number. It's always that last number that's hanging around in a quadratic equation that is in standard form. This is called standard form. I'll talk more about the different forms of it later, but for now it is that last number. So the actual coordinate of the Y-intercept is at 3, 0. 1, 2, 3 is going to go right there. Now you're probably thinking, how in the world am I going to connect those? Because on the last one, it was the vertex. That Y-intercept was also the vertex. Clearly this is not the vertex. We're going to have a mess if it is. And that would not be a function at all. But it does come around and it dips down here. But we don't know where the vertex is, and here's how we're going to find it. You may have seen this before. Okay. It's going to get crazy. Knowing that any equation that is in standard form for a quadratic, you know, and write this on a separate piece of paper or just, you know, squeeze it in the little box that you're in right now. For standard form, it's going to be in this format right here. You're going to have 3 coefficients, an A, a B, and a C. In this situation, A is 1, B is -4, and C is 3. Okay? When you are finding the vertex, the X coordinate of the vertex has a funky little formula. And again, there is a calculus explanation for why this is. When you get in calculus, ask me. I'll explain it to you. You'll love it. The X coordinate of the vertex is -b over 2a. Once we find that, we'll plug it in to find the Y coordinate of the vertex. Let's not get ahead of ourselves. Okay. A is 1. Let's start writing some stuff down. A is 1, B is -4, and C is 3. Knowing that this is the case, we're going to come over here, we're going to fill it in. We're going to find our vertex using this little formula right there. -b over 2a. Lovely. -4, opposite of -4, of course, is +4. I don't know why I had a confused look on my face just then, like I was trying to figure out what the opposite of -4 was. 4 over 2 times a, that would be 2 times 1. Obviously, that's 4 over 2. That would be 2. This is what it means. The Y coordinate is at 2 comma something. Well, I knew that because it was halfway in between. And you're probably thinking, since you already knew it, why in the world did you even waste your time going through that? Good point. The reason I did it is because sometimes it won't be as obvious. These might be kind of in between 2 dots. They might be irrational, meaning that there are radicals in there. So sometimes it's necessary to do this. Now, to find the Y coordinate, we will plug that in to the original equation. Basically, we are looking for a special y value that goes with an x value. Well, if we know the x value, this is the x coordinate of our vertex. This is the x piece. If we're looking for a special y, we can plug it in and crank out a y. So let's do that. Plug this in to find y. Find the y coordinate, I'll abbreviate that, of the vertex. Okay, so here's what we're about to do. We're going to take that 2, we're going to plug it in right there. So y equals 2 squared minus 4 times 2 plus 3, that is 4 minus 8, that's negative 4. Negative 4 plus 3 is negative 1. Y equals negative 1. So my vertex, this is going to answer that third question where it says, where is the vertex? Kind of running out of room here. Vertex is going to be at 2, negative 1. 2, comma, negative 1. Now you probably could have guessed it. There it is. Let's draw that. Boom. There it goes. There it is right there. The vertex is at 2, negative 1. And this vertex is at a maximum or minimum? I believe that thing would be a minimum. There we go. There's number 2. I'm not going to do number 3. I'm going to leave that one up to you, but let me say a couple things about it very quickly. Number 3, the vertex is going to be a decimal. It's going to be at something 0.5, I believe it is. It's halfway in between something. So don't panic when you get to this part on number 3 and you get a decimal. I think that's the only real trick on number 3. But of course, plugging in that decimal is going to give you another decimal. Also, well, I will say one more thing about number 3. On number 3, the y-intercept is obviously 12, and you're not going to have enough room to graph that on your graph. So don't panic if you're not able to graph everything, every little component of it. That's okay. All right, let's do number 4. Okay, number 4 looks a lot like number 1. It's got a little craziness to it. I'm going to go through this one very, very quickly if I can. 1, 2, 3. You can kind of tell where I'm going with this based on the numbers that I used. My Y-intercepts are going to, my X-intercepts are going to be 3 and negative 3. But let me show you why. Don't just go ahead and put that down. Let me show you. All right, X-intercepts. 0 equals negative x squared plus 9. Okay? Negative x squared plus 9. So we're going to solve this thing for x. Now, there is more than one way to solve this. I'm going to solve it by factoring, because a lot of them can be solved that way. I know I've said that. But when you factor, it's very unconventional to factor when there is a negative in front. So we're going to divide, let's actually show that. We're going to divide every term by negative 1. It is perfectly legal. You can do that. That way, 0 over negative 1, of course, is 0. X squared, negative 9. And you're going to get x plus 3 and x minus 3. Okay? So we have x equals negative 3, x equals positive 3. So it's 3, 0, I'm sorry, negative 3, 0, and 3, 0. There we go. Let's just jump to the chase here. The y-intercept, staring you in the face, that would be y equals 9, which will be the coordinate 0, 9. I didn't count that right. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll put one more. That way we can graph this. Oh! Now, the vertex is fairly obvious in this because the vertex is halfway in between those, and it's up there at the top. So it is this. I'm not going to go through all that mess that I did on that other problem to find the vertex. So the vertex is there, and it is at 0, 9. Now, different question, is it a maximum or a minimum? And the answer is obvious, but I want you to notice what makes it different. Notice that it had a leading coefficient of negative. Because it had a leading coefficient that was negative, it flipped it upside down, which means that this is a max, not a min. Now, don't say, well, we got rid of that negative. Yeah, we did when we were solving, but the original problem had a negative right there. You're going to encounter this on number 5 as well. Okay, let me scan through and show you a couple other brief things. I don't think I'm going to do any more, but I will give you a couple pointers on the next 2 or 3. Number 6, you are going to have only one X-intercept. You actually get 2 numbers, but they're the exact same. In the process of factoring and solving, you get the exact same number twice. So you are only going to have one X-intercept. Your graph on number 6, this is, I'm not telling you exactly where it is, but your graph on number 6 is going to look kind of like this. It's going to just touch at one point and it kind of bounces off the axis. Clearly, you're not going to be able to graph a Y-intercept of 36. Number 7 does not factor. This is super important. Number 7 does not factor. No matter how hard you try, you will never find 2 numbers that multiply to give you 4 that'll add together and give you 12. Won't happen. Not integers anyway. So you're going to need to use the quadratic formula when you're finding the X-intercept. In case you forgot, it is negative b plus or minus square root of b squared minus 4ac all divided by 2a. I have a song that goes with that. You will hear it later. So that's going to help you find the X-intercepts. Y-intercept is obvious. Number 8 does factor. If I'm not mistaken, it does factor. However, it's not the most obvious. So if you want to use the quadratic formula, you can. Okay? And the rest of it is up to you.